In this video, you will learn about basic data types such as int, float, char, etc. in C programming. In C programming, data types are declarations for variables. This determines the type and size of data associated with variables. For example, int marks. Here, marks is a variable of int or integer type. The size of int is 4 bytes. Basic data types. These are the commonly used data types in C programming. Here you can see the basic data types such as int, char, float, double, short int, unsigned int, long int, long int, unsigned long int, unsigned long int, signed char, unsigned char, long double. The size of int type at least 2, usually 4 bytes. The format specifier for int type is %d or %i. The size for char data type is 1 byte. The format specifier %c. The size for float data type is 4 byte. The format specifier %f. For double, the size is 8 bytes. Format specifier %lf. For short int, the size is 2 bytes. Format specifier %hd. For unsigned int, the size is at least 2 bytes, usually 4 bytes. Format specifier %u. And for long int, the size is at least 4 bytes, usually 8. The format specifier used for long int is %ld, %li. And for long int data type, the size is at least 8 bytes. Format specifier %lld or %lli. And for unsigned long int, the size is at least 4 bytes. And the format specifier %lu. And for unsigned long int, the size is at least 8 bytes. And the format specifier is %llu. And for signed char, the size is 1 byte. The format specifier %c. And for unsigned char, size is 1 byte and the format specifier is %c. And for long double, the size at least 10 bytes, usually 12 or 16 bytes. And the format specifier is %lf. Next, coming to integer data type. Integers are whole numbers that can have both 0, positive and negative values but no decimal values. For example, 0, -5, 10. We can use int for declaring an integer variable. Here is an example, int id. Here, id is a variable of type integer. You can declare multiple variables at once in C programming. For example, int id, age, semicolon. The size of int is usually 4 bytes, that is 32 bits, and it can take 2 power 32 distinct states from -2147483648 to 2147483647. Next, float and double data type. Float and double are used to hold real numbers. For example, float salary, double price. In C programming, floating point numbers can also be represented in exponential. For example, float normalization factor equal to 22.442 e power 2. Next, the difference between float and double. The size of float, single precision float data type, is 4 bytes, and the size of double precision float data type is 8 bytes. Next, char data type. The keyword char is used for declaring character type variable. For example, char space test equal to height within single quotes. Finally, semicolon. Size of the character variable is 1 byte. Next, void data type. Void is an incomplete type. It means nothing or no type. You can think of void as absent. For example, if a function is not returning anything, its return type should be void. Note that you cannot create variables of void type. Next, short and long data type. If you need to use a large number, you can use a type specifier long. Here is an example. Long A, long B, long double C. Here, variables A and B can store integer variables and C can store a floating point number. If you are sure only a small integer will be used, you can use short data type. Example, short D. You can always check the size of a variable using the size of operator. Here is an example of C program that used various data types, the format specified for those data types and the size of operator for the variables. And here is the output for this C program. Next, signed and unsigned data type. In C programming, signed and unsigned are type modifiers. You can alter the data storage of a data type by using them. Signed allows for storage of both positive and negative numbers. Unsigned allows for storage of only positive numbers. Here is an example of valid codes and invalid code for unsigned integer. Here, the variables x and number can hold only 0 and positive values because we have used the unsigned modifier. Considering the size of int is 4 bytes, variable y can hold values from minus 2 power 31 to 2 power 31 minus 1, whereas variable x can hold values from 0 to 2 power 32 minus 1. Next, derived data types. Data types that are derived from the fundamental data types are derived types. For example, arrays, pointers, function types, structures, etc. Array is a variable that can store multiple values. For example, if you want to store 100 integers, you can create an array for it. Example, int data, then square bracket. Within the square bracket, you have to mention the size of the array. Next, pointer. Pointer is a variable that stores the memory address of another variable as its value. A pointer variable points to the data type of the same type and is created with the asterisk operator. Example, int age equal to 26. Next, int asterisk ptr, that is the pointer, equal to ampersand age, semicolon. The first line shows that the int variable. Second line shows a pointer variable with the name ptr that can store the address of age. Next, function. Function is a group of statements that together perform a task. Every C program has at least one function which is main function, and all the most programs can define additional functions. You can divide up your code into separate functions. There are two types of functions in C programming, that is standard library functions, user defined functions. Next, structure. In C programming, a stack or structure is a collection of variables that can be different types under a single name. Here is an example. The struct is the keyword that is used for structure. The person is the name of the structure. And here three members are used. They are name, which is declared as char, and number is declared as int and the salary is declared as float. At the end of the structure, we have to mention the semicolon. This is the syntax of structure in C programming.